G'day, welcome back to another fun Science Minute with Dr. Joe. Today I'm doing fire, and fire is dangerous, so we don't want to do any of these things here today, at least not without professional adult supervision. Now, fires need three things in order to burn. The first thing they need is heat. Fires also produce heat. One reason they're dangerous is because they make one of their own ingredients. The next thing a fire needs is they're going to need some fuel. We're going to use these matches here. They burn at a reasonably low temperature, but anything will burn if it's hot enough. Concrete, steel, iron, even your own skin. Another reason why fires are dangerous: your body is a fuel for fire. Reason number 3 is that fires need oxygen, and oxygen is everywhere in the air around us. One of fire's main ingredients is very easy to come by. Now, these matches here create a fire by mixing the fuel in the match with the oxygen in the air, and that releases heat, enough heat so that the nearby air will glow this bright orange colour. Now, you make all the air in this room the same temperature, it'll glow just about the same colour because all hot things glow. But this is not the only chemical reaction that can be used to create fire. I've got a nifty little thing here which I can try with a little bit of aluminium foil. Strip off a bit there. I'm going to try starting a fire without any rubbing at all. We're just going to use some chemicals. Make like a little nest there. A little nest. Put that there. And what we're going to do is get this first chemical here. Potassium permanganate. Very useful, used in medicine. Fairly mundane. Fairly useful and simple chemical. There we go. Nice and safe on its own. And now we get some glycerin. This also is reasonably safe. So safe that they add it with some dangerous chemicals to make those dangerous chemicals safer. We'll call it dynamite. We're going to mix these two chemicals here, and as they mix together, they begin to react. Which is really very interesting, because as they react, they release heat. As they release heat, they begin to react faster. As they react faster, they begin to release even more heat. Eventually, this reaction, as it speeds up and up, will begin to release enough heat so that we'll begin to see some smoke. And as that smoke, we can eventually see no fire on this one either. And that's a bit of fun with fire. Now, some of you are probably feeling a bit disappointed that our last demonstration did not actually burst into flame. So we're doing it again outside, where the smoke won't affect me quite so badly. Pouring our two ingredients, let them start reacting. As they begin to react, they build up heat. As they build up heat, they react faster. Eventually that will get to the point where you should see some flame. Well, the reaction starts very slowly at times, but then speeds up. And when it does speed up, it speeds up pretty quick. If someone was to ask me, what is flame? I would tell them that it's hot, glowing air. Hot air rises, that's why fire goes up. And it's glowing for two reasons. Reason number 1 is because of its temperature. And at different points where the flame is different temperatures, it glows different colours. It's even glowing all the way up here to the roof, only you can't see it because it's glowing in infrared light. The other reason it's glowing is because of what it's made out of, the chemicals that are in the flame that are glowing. Different chemicals will glow different colours. For instance, copper sulfate will turn a fire bright green. We can also try some lithium chloride. What colour does that make? Beautiful red. Some potassium chloride. A bright purple, though it looks white on film. And one of my favourites, sodium, which is straight from salt. So now you know a flame is hot, glowing air. Catch you around.